Alright, something went wrong with the lesson numbers. It's lesson number 41, this one. Are we busy with the reduction formulas now? I told you there are certain rules. For the beginning, you're just at the tip of the iceberg. You're doing quite a few things, and then when we get it all together, it'll make more sense, I don't want to say, but then you'll see where it fits in. So whenever you get to a question that says sin 600, now we're busy with things that are larger than 360. And if it's larger than 360, you've got a rule. You just subtract as many revolutions or 360s as you possibly can. So for 600, we subtracted 360 and we got to 240. Then the first part, now you'll see me naming them number 1, 2, 3. So we've done number 1 on Friday, where you do the reduction formula, which is basically whenever there's an acute or an obtuse or a reflex angle, you are going to reduce it into an acute angle. So for 240, the first thing that you must do is realize where you are in the scheme of things. That this is 0, 90, 180, 270, 360. So that when you are at 240, you're somewhere behind 108, between 180 and 270. And there is a magical word for it. It's not really magic, it's just how it works to get back to your patterns from your graphs. So for that, we're always going to use 180 plus. Not whatever you like, not something like 200 plus 40. It's not going to work. It has to be 180 plus. Second quadrant.
180 minus
And third quadrant.
360 minus.
Okay, so those are the basics. Well done for remembering that. So if I want to go for 240, then my tool I'm going to use has got to be 180 plus. So it's going to be sin 180 plus what?
860.
Because it still has to be 240. It's not 180 plus 240. That's not 240. This still gives me 240. Then I told you about the poof sums, right? Because now the magic happens. Not really magic, it's because we are reducing it back to the first 4 quadrants. So then what happens to the 180 plus? The whole 180 and the plus goes poof, gone. And you're only left with 60. And then the sin in the front. But you have to apply wherever you were. You were in the third quadrant. And in the third quadrant, sin is negative. According to CAST, in the third quadrant, your sin is negative, which is actually where we are at the moment. Also, what we're going to be doing just now are the special angles. The special angles, 60 is one of them. So you should actually know that sin 60 is root 3 over 2.
Yes.
But your calculator will also give that to you. And if you just had to go and confirm that for this one, you can just punch it into the calculator and also make it SD to get the decimal that was negative 0, I think 99 or something like that. I'm not sure. Just check for me. What was it? Calculator?
Negative 9. Oh no, sorry. Cause was negative.
Right. For the next one then, if it's 908, if I do cos 908, I'm going to get an answer, but you're not allowed to. The rules are reduce it. What are these things called? Reduction formulas. Because of the graphs that go on and on and on and on into infinity, repeating the same old pattern forever and ever, you can always reduce it back into the first 4 quadrants, and then more than that, make it an acute angle as well. Those are the rules, because the pattern keeps on repeating. So for 908, you've got to subtract 360 as many times as you can, and you could subtract it twice. And then what was the answer?
188.
188, which is still not right, because it's still not acute. And then I've got to go and find out where is 188, and again it's in the third quadrant, so you're going to write 180 plus, and it's going to be plus 8. And then that has to be an acute angle, otherwise you're on the wrong trip. If you thought it was 360 minus, it wouldn't have worked. That wouldn't have been an acute angle. Then we go poof, and the only thing that's left there is 8 and cos. But we are in the third quadrant. From now on, if I say 180 plus, you must know that's third quadrant. 360 minus 4. 180 minus second. You must know that that's actually like a call sign. So 180 plus is in the third quadrant where cos is negative. And to prove to yourself that we are busy on the right track, you go put this in your calculator, cos 908, and you put into your calculator negative cos 8, and the answer is
Negative what?
The first answer was wrong.
9.
just 9. Thank you. All right, now guys, is this going to be a question in the exam? Nope. I'm just teaching you the techniques, the rules, what to do. If it's larger than an acute angle, what to do. If it's larger than 360, what to do. Now the third thing, you are also required to apply negative angles. So what is a negative angle? Negative angles, you can put them on your graphs and say which one is that tan of negative. If it's tan negative, you can just go to this side and then you'll find your negative angles. And it can go on and on and on. Positive angles and negative angles. The other way of doing, for instance, the first example here, I'll get back to this just now. Negative tan 40 is to say, instead of having negative 40 there, reading it off, which you can't really do because you're doing sketch graphs, it's not accurate. The other way of looking at the negative graphs is not like on the graph here, but actually physically measuring from standard position on the positive x-axis. You're measuring positive angles. We measure from there up to 90, 180, etc. I'm going in which direction? Anti-clockwise are positive angles. It feels kind of like the opposite way around. Anti-clockwise is the way to measure positive angles. So if you're measuring a negative angle,
Clockwise.
you're going to go clockwise. So for that tan negative 40, you should be over there. It doesn't mean that there's less than nothing of an angle. It's only the direction that shows me. It's still going to be 40 degrees, but just in a different direction. So what I'm trying to teach you is what is negative angles. Okay, are you with me? On a graph, the tan graph, or actually going with your revolutions and measuring a certain size. Now the rules for this is very technical again, none of them are. What you do is you make the angle positive. So here's my question. Make the angle positive, so what's it going to be? Plus 40. But then you make your, what's the ratio? Sin, cos and tan are the ratios. Are you with me? Sin, cos and tan are ratios, trig ratios. So you make the angle positive, but the ratio you make negative. So this is going to be tan, but with a negative in the front. But there's a little curve to it still, except for cos. Now it wasn't cos, so no problem. Now I have to convince you that this is true. That's why I'm using actual numbers. So if you go to your calculator and you put in tan, and it waits for you there with a bracket, right? Negative 40. What does it give you? Negative? 84. And if you put in negative tan 40, because you've got to put in negative tan 40, what does it give you? Same thing. I'm trying to convince you that the things I'm teaching you is true. Okay. But now, if I go to the sketch of the 40 that I wanted to show you, if you then do that and you make that angle a positive, what's going to happen to it? It's going to be over there. Are you with me? If I make it positive, but it's not supposed to be there. The original one was here, and it had an original value of negative. So you just can't take the positive value and say that that's now the answer. That's why these rules have to go and apply. All right, let's do a few more, then I'm going to show you something else. So if it's negative 130, what do you think we're going to do? Ma'am, here's the rule. You make the
Positive 130.
angle positive and the ratio negative, but I want you to always say except for cos, even if it's not. I want you to do the choral verse with me. Negative angle becomes a positive angle and the ratio becomes negative except for cos. And then, am I finished with that sum?
No.
Why not?
Because
you were taught to always go for acute angles. 130, You're going to have to say 180 minus 50. Which is then going to be a what sum? A poof sum. Right? 180 minus goes poof, gone. So we're left with 50 and with sin. But we are now in the, which quadrant? Second. 180 minus is the call sign for second, and sin in the second is positive. But what about that minus? Nothing happened to it, it's still there. So it's actually minus, and then this was a plus. So the answer will be negative sin 50. So that I can convince you. Go to your calculator, punch in sin of negative 130, punch in minus sin 50, you'll get the same answer. Alright? But now remember all the stuff that's happening, it's growing. If it's negative, what do you do? If it's bigger than 90, what do you do? Okay, I made this a nice easy one again just to show you. It's a negative angle. I hope that you'll be able to realize and recognize it's a negative angle. So you make it positive, but the ratio becomes negative except for cos. So it stays positive. Convince yourself. Punch in cos negative 70. Punch in cos just 70. And what's your answer?
0.34.
Okay, depending on how I wanted it to be rounded off. And that's your answer. Now, so the rule is, go back to the more technical way of writing it. If I say sin of a negative angle, I'm putting a theta now. What's going to happen? You make the negative angle a positive, but the ratio becomes a negative except for cos. Make the negative angle a positive angle, and the ratio you make a negative except for cos. So for now, put the plus there. You have to put the plus there. No, it's just for now to make sure in your brain you're talking to yourself all the time. Negative angle becomes a positive, the ratio becomes negative except for cos. So the last one will be negative angle becomes positive, the ratio becomes negative except for cos. It's not cos, so it's negative. And those are the general rules without being able to be working with an actual number. Alright, something else I want to show you. Thinking about that negative. If it was that negative 40, cos in this quadrant is positive. That's the whole reason why it's not cos that's negative. Now you can tell me, but ma'am, if it's more than an acute angle, what then? You're still going to always make it acute, whether it's negative or not. Always make it acute. And if it's acute, it should be in the fourth quadrant than if it's in the negative direction. I'm going to teach you always to first sort out the negative and then to sort out the bigger than stuff. But you could just as well have first sorted out the larger than and made it smaller, acute, and then you can go and sort out the negativity of that angle. But this is actually the reason why cos is positive. Because if you take any negative angle and make it acute, where will that be? An acute angle that's negative will have to be in the fourth quadrant, where cos is positive. That's the reason. Okay, but there's rules. So, do you see that there's lots of stuff to know on the tip of your fingers? Alright, let's do a few more. So what do you think Ben just said to you? What must you do with the negative angle first?
Make it positive.
Make it positive. So this will be positive 340 of sin. But then the ratio, which is sin, has to be negative because it's not cos. Alright, and then it's not an acute angle, so 360. You're going to make that mistake and say 180 plus. But if you said 180 plus, it should have been 180 plus 100 something. Are you with me? Yeah. It's not acute. Then you find out very quickly on the wrong space. So it's 180 of 360 minus 20. That tells you, okay, that's fine. It's an acute angle. Then we go poof, sin 20. Are you with me? Yes. But you are in the fourth quadrant where sin is. And it already has a negative there, so you're going to have this situation. Are you with me? Which is going to become a positive. Positive sin. 20. Now, depending on what the question was, did I want you to go and get the decimals or don't I want you to get the decimals? For now, we're just getting you into the techniques. This is not a sum and a test. Okay. Last one quickly, because I can go punch it in the calculator and get 0, whatever. Are you with me? Again, a negative angle. I make the negative angle a positive and make the ratio negative?
No.
No, because not cos. Ratio, angle is positive, but the ratio is negative except for cos. So for now, it's not a bad idea to always write plus there. And then 280, I've got to reduce to an acute angle by saying 360 minus 80. That's going to go poof. Are you with me? What goes poof? The 360 minus, that's the unit that goes away. 180 plus, 190 minus. So when it's gone, I must check in which quadrant am I? Fourth quadrant cos is? Positive. So if you want to write it as a plus there, I'm perfectly happy with you. If you want to write the answer in a decimal now, we're just playing around. We need to get to the actual sums that you're going to be asked in a question paper. So now we've done number 3, which is the negative angles. Negative angles larger than 360. It can be negative and larger than 360. This could have been minus 3,000 and something. Then you would take away the 360s and apply the negative and reduce it back. Are you with me?
Yes.
Okay, special angles is nothing new. What are the special angles rating?
0, 60, 90.
0, I hear, 60, 90, 45, yeah. I heard the 0 and I like that. Because normally when I ask kids what are the special angles, this is what they say. They are not the only special angles that they are. Yes, they are special, but then what about 0, 90, 180, 270, 360, etc. You can go 90 further is 450, etc., etc. And how do I require you to know that without a calculator? Remember last year we said, teacher will say no calculator, but you're going to use it anyway? Okay, I've got to remind you of this. If you're going to go and want to do the NDT tests because you want to go do engineering, you want to go do medical sciences, you're going to have to go for those tests that in your application. Are you with me? And you're writing maths with no calculator. So if they ask you what is sin 60 like I did over there, you should know that it's root 3 over 2. Now how do you know that?
Special
There are 2 triangles that I teach my kids and there are different variations. The 2 triangles I teach you is, if this is 30 degrees, that's 90, then this should be 60. Why? Okay, are you with me? So from this triangle, you are taught what sin, cos, and tan of 30 and 60 are. But you have to know that, and my teacher told me this millions of years ago, that sin 30 is a half. So it's going to be sin is opposite over hypotenuse. Are you with me? And then if I know that, how do I get to this one? Pythagoras. But you should actually just know it. Now guys, there are various techniques. I know one of them is the teachers tell the kids to draw it like on a radius circle thing, and they've got these coordinate things. I'm not even going to show you that. Whatever you need to know that, I don't care. As long as when I ask you for cos 30, you know that it's root 3 over 2, I'm happy with you. Where you get it from, I don't care. This is the way I teach my kids because this is the way I was taught. So if I know that, I can know sin, cos, tan of 30 and of 60. The other one that you are taught or were taught is 45. Now again, tell me what this is.
1,
45, right?
45.
And which makes this triangle a what triangle? Isosceles, which makes these 2 sides equal. And what are their lengths? We normally say 1, but can man say 6? Yes, I can. Because remember that sin, cos, and tan are ratios. They are not values. The side must be 6 and the side must be 6. The ratio must be 1 to 1. That's the way you were taught, was 1 to 1. But if I want to call this one 6, then this one has to be 6. Because you're going to get into sums where they give you a 5 there. And you're going to know that they've got to be equal to each other and find the other one using Pythagoras. But the way you were taught was that this was both 1. Because it's still the same principle. Ratios are 1 to 1 because they've got to be the same if this angles are equal. Sides opposite equal. Angles, and then this with Pythagoras worked out to root 2. And then when you did sin 45, for instance, you just go to the calculator because ma'am said it's okay. But if you're not allowed to do that in the NBT tests and you're sitting without a calculator, you would say that sin is opposite over hypotenuse, which is 1 over root 2. What does your calculator say? Not the same thing. Why does your calculator do that?
Because it's
Because you shouldn't have irrational numbers in your denominators. It always rationalizes the denominator. But if you write this in a test for me inside of your sum, it's fine. Just at the end of a sum, make sure that you've got your roots at the top and not at the bottom. Are you with me? So this is old, very, very old work. But we've only got 30, 60, and 45 here. So how do I just expect you to know what is sin 90? Quickly tell me what sin 90 is. Don't touch your calculator. 1. Quickly tell me what is cos 90. Cos 90. 0. What are you guys doing? The ones that are getting it right, what are you doing?
Oh!
You're thinking graph. This is the reason I always do the graphs first. Because if I ask you for tan 360, you should know that when you're sketching it, 360 is 0. Without calculation. And 45, yeah? You should know it's 1 because that's the way you were taught to sketch it. That tan 45 is 1. And in any case, tan 45 is opposite over it. Jason, are you with me, guys? You must see the whole thing coming together. Alright, so that's the reason I say there are not just 3, 30, 60, and 45 that's special angles, but all the rest as well. And even going on and on and on till forever, in multiples of 90 further on, it will stay the exact same thing. Okay. So quickly let's remind ourselves about the special angles. So if I say sin 30 in this exam coming up, I just want to know whether you know it's a half. Whether you did it on the calculator or whether you did it on your little triangle or any other way that you know how to, that's your answer. Are you with me? You have to know what you're aiming for and working for and what you need to be able to do when you have to go write tests for enrollment. Cos 60. There's also a half. Go there, cos is adjacent over hypotenuse. But by the way, I'm getting there just now, just tomorrow, with the co-functions, because 30 and 60 have got everything to do with each other. 30's sin ratio is opposite over hypotenuse, but 60's cos ratio is the exact same two sides, but it's adjacent over hypotenuse. I want you to take a note of this to know about the co-functions, and you did touch on that last year, but I'm sure you forgot. That sin 30 is exactly the same as cos 60 because they make up the 90 that's I'm short inside of my right angle triangle. Okay, we'll go to that tomorrow. Tan 45 you just told me was? Because I know how I'm sketching it by 45. Calculator tan 45, 1. Sin 180, do it without a calculator? 0, excellent. Tan 360 we just did? 0. Are you with me, guys? But if you're in a test here, in Hoërskool Alberton, and you're writing math, I'm never ever going to say without a calculator, and you're not allowed to take the calculator in there with you. I must just not be able to see that you only use the calculator with a big sum and you got the one answer, no marks. But the little bits and pieces you can do with a calculator as well. So those were your special angles. Now tomorrow you can write the fifth piece is going to be co-functions. Okay, we're going to do co-functions tomorrow, and also we're going to do identities tomorrow. Right. Homework?